Hello guys, welcome to Leetcoding. In this video, we are going to see the Leetcode problem number 26, remove duplicates from sorted array. Let's get into the problem. So the problem statement is, will be given an integer array nums sorted in non-descending order. You need to remove all the duplicates in place. So we'll discuss about it later. So we need to remove the duplicates such that each unique element appears only once. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result placed in the first part of the array nums. More formally, if there are k elements, after removing the duplicates, then place the first k elements on the first k cells of the nums that is given array, and you need to return the k finally. So it doesn't matter how you leave the other remaining elements except the first k elements. So you need to return the k, which will be the number of unique elements. So we do not need to, we should not allocate any extra space for another array, but we need to do it by modifying the given input array. So which is the meaning of in place. So in place is nothing but an algorithm which transforms input with no auxiliary data structure. A small amount of extra storage is allowed for auxiliary variables. The input is overwritten by output of algorithm. An in-place algorithm updates its input sequence only through replacement or swapping of elements. So we don't use any extra space, but in-place is nothing but using just the given input. So we won't create any extra space, but just modify the given input array. So that's it about the definition of in place. So now let's get on to the approach. So let's go to paint. So firstly we need to define the problem. Before moving on to any approaching of any problem, we need to define the problem. So firstly the input is an array which held as nums, and output should be k, which is unique count, unique element count. But and also there is another output. So only unique elements in k positions or duplicates removed. Duplicates removed and unique stored in front, stored at front of nums, which is the given array. So we'll ignore this. So we'll be given the input as an array nums, and this is said to be sorted. This is in the sorted order, and we need to remove the duplicates, yeah, and place the unique elements in the front without changing order. No change in order. No change in order. So this is all about the problem. Is there any corner case to be discussed? So in the, what happens if the input array is 0, that is the length of nums is 0. If the length is 0, we'll just return 0. So is there any other corner case? So what are the inputs? What is what are the elements will be present in the given array? So given array will be consisting of integer. So so any other corner case to be discussed? So I think we have covered every cases. Let's verify it once again. So yeah, they have given the range in which each element will be present. So okay, now let's move on to approaching this problem. So how can you approach this problem? So the first approach that comes to everyone's mind would be to use a priority queue. So you can use a priority queue and insert every elements. You use a priority queue, and if the array is let's say 1 and 2, so yeah, it will be in ascending order, right? So if there's a 1 1 2, we'll add every element to the priority queue, and we'll start with the keep track of current index. So in current index will be 0, right, initially. So we'll pull the element and add it to the current element. So we'll move to the next index. So now once again we'll poll and we'll check the previous element. So the previous element tends to be 1. So we'll just continue popping. So after we poll 2 from it, we can see that previous element is not equal to current element. So we'll replace it by 2, and we'll once again we'll try to poll, but there is no element. We'll stop the process and we'll just return the value of current index plus 1. So this is the first approach. So we have used a space complexity of big of n. So can we reduce the space complexity? And the answer is yes. So how can we reduce it? So consider this example. So each time we just need the previous element. So each time we just need the previous element. So what is the previous element? This is the only thing we need now. So for each time we keep track of only the previous element. So initially we'll start with the given array. So for each time we'll need only previous element, right? So we consider this as, so let's index the cells. So we'll start with first index. So this will be let's include the first element in the given array. So we'll start with this first index. So we'll check with the previous element. So the previous element is not equal to current element. So we'll increment it. So we'll have two pointers, which is one is current, it's called as URR, and I pointer. So we'll move here and we'll check the uh, previous of current value. So the previous value tends to be previous of current tends to be 2, which is equal to current value. So we'll just increment the I pointer. I comes to third index and we'll check the previous of the current pointer. So previous of the current is 2, which is not equal to 3. So we'll just replace 3 in the current index and increment the current index and also the I index. So current will be pointing to third index. Now we'll compare the current element with the previous of current index. So now current index is 3. So we'll check with the previous element, which is 3. So 3 is equal to 3. So we'll just increment the I. So I comes to fifth index. So now we will check the previous of current index. So previous of current included. So current index is nothing but currently included in element. So we can clearly see that 3 is not equal to 4. So we'll just replace the 3 by 4 and we'll increment the I and also the current value. So after this we can clearly see that we have came out of bounds, and finally we just return the current value as k. So finally we'll get the output as 1 2 3 4 3 4. We don't need to care about the remaining elements, so only the first unique element. K elements are matter here, so k is 4 in this case. So in this case our space will be big of 1 and time will be big of n. So the space is big of 1 since we just use the given input array. So we haven't created any other extra space. So that's all about this approach, guys. So you'll be very clear in the coding section. Now let's move on to coding section. So we'll have current pointer as 1. So initially, if the given input array length is 0, we return 0, or else we'll have current index as 1 and also I as 1. So while I is less than while I is less than the index bound, we'll check the um, current element. So which is nums of index, the ith index element is equal to not equal to nums of currently included element minus 1. In that case, we'll add the we'll replace the current index with index and the element at I, and we'll increment the current, or else we'll just increment the I pointer. So finally we'll return the current value. So let's set this up. So yeah, that's working fine. Let's check with the other test case. So let's submit it up. Accepted. So that's all about this problem, guys. And approach for this problem would be two pointers. So that's all about this problem, guys. Thanks for watching this video. Have a great time.